In this video, I'd like to continue talking about the distance between 2 points, or finding what that distance is. And in the previous video, we looked at a specific example where we had two distinct points on the coordinate plane. But in this video, I want to focus on finding a formula for any two given points. So we're going to talk very generally here. We're going to start with a coordinate point, which we can call x1 comma y1, where x1 and y1 can be any x and y values. And we'll compare that to the point x2 comma y2, where again, these can be any possible values of x2 and y2. And we want to find the distance between these 2 points. So let's say this point right here, x1, y1, is maybe right here for its x value and right here for its y value. So its coordinate point can be right there. And let's say for this point, x2, y2, that its x value maybe is right there. And its y value can be up here so that this point is right there on the plane. And again, what we want to do is find the distance between these points. And keep in mind that this is very general. These points can be anywhere on the plane. It's just that I've drawn them right here. But if you want to retry this exercise, you can draw them wherever you want. So we want to find the distance between the points. So if we draw a straight line, essentially we just want to find the length of this line. And we will call this d. So d is the distance, we can say, between the points. And the general strategy here is that we essentially want to make a triangle with these points in this distance here. Specifically, we want to make a right triangle. So you can imagine dropping a line straight down from this top point to the x-axis below. And we could do the same thing here. And we'll do the same thing with our y-coordinates, except we'll make horizontal lines, so lines straight across, going from there to here. And notice we can make a triangle. So I'm going to draw the lines in a little bit clearer. But the key idea is that these lines are going to go straight down and straight across. And they have to be vertical and horizontal because we need a right angle here. This needs to be a 90-degree angle here so that this is a right triangle. And because we have a right triangle, we can use the Pythagorean theorem to relate the sides of this triangle. So remember that if you have some general triangle or some general right triangle where we know the side lengths, we can call this A, B, and C, then the relationship between these is that a squared plus b squared is equal to c squared. So remember, this is just the Pythagorean theorem. And we'll use this to find a formula for the distance between these 2 points. So we just need to figure out what these side lengths are going to be. And let's start with the vertical side here. So notice that this has a y value at y2. And this right here, this bottom here, this would be at a y value of y1. So to find this length, we essentially would just subtract the two. Since think about it if there were actually numbers. Like if this was 8 and this was 4. To find this length here, you would just take 8 and subtract 4. Or you can imagine counting, going from 4 to 5 is 1, 6 is 2, 7 is 3, 8 is 4. So whatever the top y value is, we will subtract the bottom y value. And that will give us this side length. So let's write that in, that this side length will just be y2 minus y1. And likewise, for this horizontal side here, notice that its highest x value right here, this has an x value of x2, and its lowest x value is at x1. So again, imagine if there were actually numbers here, like this was 2 and this was 5. This length, you would just take the larger number and subtract the smaller one. So in that case, you would get a side length of 3, which again, you can just imagine counting. Going from 2 to 3, that's 1, 3 to 4 is 2, and 4 to 5 is 3. So we're going to take the larger x value, x2, and subtract the smaller x value, x1. So this triangle here, its hypotenuse is length d, its bottom side is the difference between the x values, x2 minus x1, and its vertical side is the difference of the y values, y2 minus y1. So we can redraw this triangle to focus on it a little bit better. And let's relabel our sides here. So this is D, and by the way, we do know this is a right triangle. This vertical side, that was y2 minus y1, and our horizontal side, that's x2 minus x1. And from here, we want to apply our Pythagorean theorem so that we can figure out what D is. So to do that, we know the legs of our right triangle are labeled as A and B. And it doesn't matter which we call which. What does matter is that the long side, the hypotenuse, that's what we label as C. So maybe we call this y2 minus y1. Let's call this B. And it's the entire difference. And this x2 minus x1, we can call that A. So that leaves us with the hypotenuse, which we have to call C. So let's now apply this formula. So we have a squared, that's x2 minus x1, and we're going to square that. And then we add b squared, but b is y2 minus y1, and again, we're squaring that. And this is equal to c squared, which is just d squared. Now, this is our formula relating the sides of our right triangle here. Or essentially, this formula will tell us, given any two coordinate points, what the distance is. Though it's usually better to actually solve it for D, so we can get rid of this square here. So remember, to cancel out a square, we want to take a square root of everything. And we have to take a square root of the entire left-hand side here. So when those cancel out, let me just make a little bit more room. We get the final version of the formula where D is simply the square root of the difference between the x values squared plus the difference between the y values squared. So this is our formula, and this formula makes it so that we don't have to draw a picture and then use the Pythagorean theorem every time we want to find the distance between 2 points. So it's a little bit complicated looking, but it's mostly just labeling what the points are and then plugging them into the formula. So in the next video, we will look at a specific example of actually using this formula.